Hello students, in this video we'll discuss about pumping lemma and closure properties. So in the last video we have discussed about applications of finite automata and decidable properties we have discussed. So this video, closure properties. And what does it mean by pumping lemma? See, first of all, pumping lemma is used to check whether a language is regular language or not. So means if you want to say that a language is regular or not, you are given a language and you are asked to check whether it is regular or not. Then what do you have to do? You have to use the pumping lemma. If this language does not satisfy the pumping lemma, does not satisfy pumping lemma, then it is not regular. It is not regular. So if it is satisfies the pumping lemma, that we cannot decide whether it is regular or not, we cannot say it. Okay, if it satisfy, may or may not be, may or may not be, but if it does not satisfy, then it is not a regular. So if you are given a language and you are asked to prove that it is satisfying or not, of course you apply this lemma. If it is satisfying, well and good, you cannot tell some answer. If it is not satisfying, you can conclude that it is not regular. So that's why most of the cases in exam you'll be given a languages, definitely they are not regular. 100% whatever the languages so far asked in the external exam, by saying that the show that the pumping lemma and check whether it is regular or not. Till now, whatever the questions we got in external exam, 100% questions are not regular only. So your intention is to do like that, but of course I'll tell you the statement how it is going to be, right? See guys, what does it mean by regular? As I told you already, if your language is infinite and you want to represent it as finite automata or finite state machine, something should be pumped iteratively, right? Either it before that or after that or middle, it can be anywhere, but something should be iterated. Before that you may have nothing or something. After that you may have nothing or something. But whatever the part you are taking, that should be iteratively. If you have such identification, then we can say that it is satisfying the lemma and we can say that it is regular. Sorry, may or may not. If not, if you can't identify such, then it is not a regular. Now how to do it? First, you are asked to prove that whether language is regular or not. You take the language L and you assume that there could be some states, and which is n, and take any string with the length greater than or equivalent to n and divide that string into three parts, x, y, z. How you have to divide that string into three parts such that the first length of the xy is less than or equivalent to n, whatever you have assumed. The length of the y should be greater than 0, means it must not be epsilon. You take something. This is a pumped one actually. This y is the pumped one. Pumping epsilon won't affect on your language. That's the reason it should be greater than 0. And for all I greater than or equivalent to 0, the x, y power I, z must be in the L. If so, you cannot tell whether it is regular or not. If no, then we can say that the language is not regular. Remember this guys, same thing we are going to use for the context-free languages, pumping lemma for, this is we are discussing for regular, right? Whatever the pumping lemma we are discussing. So we'll be having the same pumping lemma for context-free languages also. At the time, what would be the change that we'll discuss, right? Let me explain this. Of course, if you have some doubts here, let me explain this with a simple example. Definitely you'll understand it, right? Let me go with this. So we have climbed is not regular language, but how? How can we prove it with the pumping lemma, right? So here how many variables we are having here, and then take some string which is 2 or more than that. Because if you assume that it is a regular language, then you should have at least two states, like any number of zeros followed by any number of ones or equal number, you should have two. And it's two. Assumption only. So I'll assume three. That's your wish. You do it, whatever, nothing will be happen. Okay, you assume. And you have to take the string, like any string, which is greater than or equivalent to 2. That's what the condition is, right? The second condition. So any number of zeros followed by equal number of ones, I'll take 0, 0, 1, 1. So where the length of the string is 4 and it is greater than or equivalent to n, satisfying, yes. Okay, then we have to divide the string into x, y, z. So that's your wish how you have to divide it. But should satisfy this. Length of xy should be less than or equivalent to 2. So then how can I do it? Length of xy. So this should be xy because it is not more than 2. And this could be z. So what is our xy here? 0, 0. And the length of 0, 0 is 2, which is less than or equivalent to n. Yeah, satisfying. And there is no restriction on z. You can take it double one. There is no conditions on z. And again, you have to divide this xy into x and y. So x can be epsilon, but not the y. So y should be greater than 0 according to this rule. Then I can say that this is y. Even you can take two zeros also y. Is that time x is can be epsilon because they didn't mention anything about the x. Only x. So here what it could be, then you can write it. So the length of y equivalent to 0, the length of 0 is 1, which is greater than 0, satisfying. And what is x here? 0, as there is no condition. And what we can do here, take I equivalent to 1. X, y power 1, z belongs to L, otherwise it is not regular. X means what? 0, y means 0, z means 1, 1. Yes, it is belongs to L. Number of zeros followed by equal number of ones. You take I equivalent to 2, x, y square, z should be belongs to L, otherwise it is not regular. So x, y, z should be belongs to L. X means 0, y means 0, one more y means 0, 1, 1, but actually it is not belongs to L. Our assumption is made wrong. Then we can say that the language is not regular language. So this is how we can prove that whether it is satisfying the pumping lemma or not. Of course, why I took this language, this was asked n number of times in the external exam. You may be given some other, for example, if you are given L equivalent to 0 power n, 1 power n, 2 power n, you take the n as 3, right? Then you go for it. You'll definitely just follow these rules. You'll understand what exactly it would be, right? Follow these three rules. So the next concept is closure properties of regular sets. See, what does it mean by closure properties? And it is denoted with the plus, or you can say that L1 union L2. What does it mean? See, the regular languages are closed under all the properties which is mentioned here or not mentioned. Even though it is not mentioned here, the regular languages are closed under all the properties. What does it mean? Right, let me go with the first union. If L1 and L2 are two regular languages, then L1 union L2 must be regular language. Then only we can say that regular languages are closed under union. So if you want to can write definition like regular languages are said to be closed under union if L1 and L2 are two regular languages, then L1 union L2 must be a regular language. For example, L1 equivalent to A star B, L2 equivalent to B star A, right? Both are regular because represented. What is L1 union L2? It's a very simple thing like A star B union B star A. This is also a regular expression, so it is a regular union. Then concatenation, same. L1 concatenation L2. So regular languages are closed under said to be closed under concatenation. If L1 and L2 are two regular languages, then L1 concatenation L2. L1 concatenation L2 means what? A star B concatenation B star A, like that. So then you can say that clean closure L star, same. If L1 only one is enough, is regular language said to be closed under clean closure, then L1 star, right? L1 star must be a regular. So A star B whole star, of course it is also a regular. There is no problem with that. Intersection L1 intersection L2. So you have to take the common symbols in between both L1 intersection L2. What it is, any number of A's followed by 1B, and here any number of B's followed by 1A. Are you going to have any common strings here? No. Then it is empty. Even empty set is a regular language. That's the meaning of it. No common strings in both L1 and L2, but still it is a regular language. So what does it mean by complement? L complement is nothing but sigma star minus L. For example, how to get the complement? See, you will be having starts with AB in our automata. It is very easy to explain with the finite automata. So B and A comma B. So what is the strings accepted by it? A comma B starts with AB. The minimum is here AB, AB, A, AB, B, like that. How to get the complement of it? Does not starts with the AB. That's the meaning of it, right? So simply to get the complement of this machine, right? Complement of this machine, interchange the final and non-final. Here it is non-final, make it non-final, and move everything is as final. See, now epsilon not starting with AB, B, AB starting with, so it is not going to be accepted. So how to get the complement of a finite automata? Simply by interchanging the final and non-final states, but make sure that that must be a DFA. But if it is NFA, by interchanging you can't get it. You can't. So what is this L complement that we have discussed in the first video and even second video of the first unit? You just go and check it. How what is this starts with, does not starts with, right? I explained with the diagram also the complement. So now just we are dealing with the regular languages. So how to get the complement of a finite automata? Just by interchanging the final and non-final states. So what does it mean by reverse? It's nothing but L1 minus L2. For example, if L1 equivalent to A star B and L2 equivalent to AB, right? So what is L1 minus L2? We have to take all the strings which are not in L2. Means here only B is allowed. You can take it. Only B. But single AB is not allowed. Two ABs are allowed. Then you can take A plus B, the positive closure. So if I take one, you can take it. But two, at least two, right? Then you can write one more A here. So 1, 1, B, 1, 2, 3. Or like plus means 1 to infinite. So you have to take B. Of course, it's not here. You cannot take AB because AB is in L2. But I can take AAB. No problem. I can take A triple AB. So on. That's the difference. Reverse. And it is denoted with reverse R. So simply interchange statements here. Like for example, if L equivalent to A star B star, then you can get the reverse by B star A star. Okay. So like you can find the it. So that's why I told you if some properties have mentioned here or not. But if two languages are regular, perform any operation on singular two, the resulting must be regular because all properties are closed under regular languages. So in the next video, we'll discuss about the Mahel-Néron theorem or minimization of finite automata.